they seem to meet at the far end. So that means that they will meet. Or look at the roads, or look at, in other words, parallel lines that extend. When you extend indefinitely, they meet. So the mathematicians answered that by saying, that's not Euclidean geometry anymore, because that's another world. That's another kind of, if we say nation, if we compare to a nation, another country that is non-Euclidean country. So we have, and we call that projective geometry, parallel lines meet. But right now, we are interested in Euclidean geometry only in our immediate surroundings. Okay. Now, the question here is that if you have three lengths, or say toothpick, A, B, C, can you always form a triangle? So you have read already. Okay. Why not? Look, for instance, suppose that you have this and this. Three lengths, no? Take note that when you connect end to end, you can never form, because this look, I mean, iba naman. Kunyari, ay. Oh, ito, kunyari. Oh, itong ano na to. At saka ito, isang length din yan, isang length din ito. Kahit anong gawin mo, hindi mo mapagdudugtong end to end. You cannot really always form a triangle. So, makakabuo kaya kayo ng tatsulok. Tatsulok means triangle. So, kung ang sagot ninyo ay hindi or no, ayan, so correct kayo dyan. So, that's correct when you say that you cannot really form a triangle for any three sides. So, we have what we call the triangle property. The triangle property says, so we'll just write the rule, okay. So, this is the rule. Actually, these three inequalities say that you can form a triangle if the sum of any two sides is greater than the third side. The sum of any two, if you get the sum of these two, it should be larger than this, but it's not. So you cannot form. So the rule there is the sum of any two sides should be larger. Like these ones, if you get the sum, it's always larger. Sum, always larger than the third side. So these three lengths can form a triangle. So we call that the triangle property. Or, that this is what these three equations, inequalities tell. Or, just one of them, just one of these. What do these inequalities say? It just says that given any length, it should be larger than the difference. So if you get the difference between these two, the difference will be that small thing here. It's really larger, but greater than the sum. But the sum is greater. So it's meaning, taken any side, it should be between the difference and the sum. Now, in that case, then certainly you can form a triangle. So for instance, what if you have 1, 1, 2 as sides, 1 inch, 1 inch, 2 inches? Can you form? Why not? 1 plus 1 is 2. The sum is not greater than the third side, which is 2. Okay. But how about 3, 4, 5? Yes. Take any side, say 4. 4 is greater than the difference of 3 and 5, and it is less than the sum of 3 and 5. So 3 and 4 certainly can form a triangle. Now, there is another formula which we call the Pythagorean theorem. I want to go back to that formula. Suppose this is the Pythagorean theorem. A squared plus B squared is equal to C squared. Meaning that if you have three perpendicular sides, we call this the legs of the triangle, and this is the hypotenuse. Now, according to the Pythagorean theorem, the sum of the squares of the legs is exactly equal to the square of the hypotenuse. Now, the hypotenuse is always the largest length. So when I say 3, 4, 5, if this were sides of a right triangle, what is the hypotenuse? 5. Will this, first we know that they form a triangle, right? Will they form a right triangle? Look at the sum of the squares. 3 square is 9. 4 square is 16. What is 9 plus 16? 25. Now, what is this hypotenuse? 5. Square that. 25. They are equal. So, 3, 4, 5 can also form, not only, well, of course, it can form a triangle, but not only triangle also can form a right triangle. Now, regarding the Pythagorean theorem, this is called Pythagorean theorem. Now, the Pythagorean theorem, we do not know if that really was due to Pythagoras. Because during the golden age of Greece, during the Greek period, they had what we call the Pythagorean Brotherhood. This group of intelligent men are mathematicians, they are artists, they're also politicians, statesmen. So, and they think, and I mean, because during that time, these types of people belong to the upper class. So everybody really want to belong to that. However, the Pythagorean Brotherhood also became occult, meaning they attribute divine things to numbers. But then, they are also mathematicians. And if anybody comes up with a formula, it is not attributed to the person, but to the brotherhood. So the Pythagorean theorem, we do not know now if that is due to Pythagoras. Okay, as I was saying, the Pythagorean Brotherhood was very powerful. It became very powerful, such that the government disallowed it. Has declared that it is illegal. So, when the Pythagorean Brotherhood was dissolved, then of course, if they know the theorems is due to this person, then by this one, by him. But if they don't know anymore, they say Pythagorean Brotherhood. A remnant of that, because of their Greek practice of attributing divine to numbers or human to numbers, as in memory of them, we have rational numbers, okay? Rational or irrational number. When you say irrational, it doesn't mean he's out of his mind or he doesn't think well, but it's just that in memory of our mathematical ancestors, that they attributed human adjectives to numbers. So just that. When we say imaginary, it doesn't mean that there is no such numbers. There are such numbers, but except that they are called imaginary, meaning they are not real numbers. Negative of real numbers. Okay. So now we go to something that they were able to measure, which is what, as I have mentioned, the divine proportion. You can also consider the divine proportion also comes from the golden rectangle, gininto ang parihaba. The golden rectangle, it has a very specific dimension, golden rectangle or gininto ang parihaba. If this is a golden rectangle, and this is the length, and this is the width, then also the ratio of the length to the width is equal to phi. And the phi, we can find out later, is 1 plus square root of 5 over 2. We call this the divine proportion. We can show that. So first, we show, now the golden rectangle is made from a square, no matter what size. Even very small square or very large square, you can always form a golden rectangle. How do you do it? That's where bonus 4 comes in already, no? So how do you form a golden rectangle from a square? So this is our mission. Construct a golden rectangle. Construct a golden rectangle from a square of side 4 inches. Okay. And then we'll show later, to prove that the rectangle that we constructed is a golden rectangle, the ratio of the length to the width should be a divine proportion. What is the divine proportion again? What? 1 plus square root of 5 all over 2, or in rational number, approximately 1.62. Okay. So, square. Then, square. So, 4. So, let's call this A, B, C, D. Get the midpoint of a side, say CD. Call that M. Then so if this is midpoint, so this is 2, that is also 2. And this is 4. Then what is MB? By Pythagorean theorem, the legs are 2 and 4. So what is MB? Equal to. So MB is equal to square root of B square, 16, A squared plus B squared plus 4. Square root of 20, we can write 20 as 4 times 5. And 4 is a perfect square. What is square root of 4? 2. That is 2 square root of 5. So square root of 20 or 2 square root of 5. That is MB. Now, the golden rectangle has the same width, but the length is this one, cm. The length is cm plus mb. So, by the way, the Greeks never used ruler, no? They only used compass and straight edge. So, how can they measure MB? They do not measure, it is 2 point something, so 2 point something. No, only straight edge without measurement and compass. So what they do is that with the compass, they put the point here and then the pencil there, and then there. It will intersect with a straight edge. They'll elongate that one. So suppose that it will intersect the MB, the arc MB will intersect the line, the prolonged line CD at E. So therefore, L is CM 2 plus ME. So 2 plus ME is 2 square root of 5. And then the width is the same width as the original square, which is 4. So, let us consider length over width. What is it? Length is 2 plus 2 square root of 5. Width is 4. So, that will be, the 2 will cancel. That will be 1 plus square root of 5 all over 2. You can factor out the 2 before you cancel. So, that is now, see, this is the phi. This is the phi that we know. So, saan ba ito matatagpuan? So, we can find this in the architecture. In architecture, the Parthenon,